online. And if you guys want to go see it, because I do tend to speak a little fast, and especially if I get a little excited, which tends to happen. It's been known to happen, especially when I'm presenting. So thank you, everyone, because I know it's the last session of the week, and you're probably eager to go back home or just to your hotel and go to the pool. So I appreciate that you came here instead of the swimming pool. I also know that there's a lot of good sessions. So if you're kind of debating between two sessions and you decide to step out in the middle of the session, I'm not going to be offended. So, but if you can stay, and I hope you're going to be learning some new things. So the title of the presentation is Save Time, Money, and Sanity with Unit Testing. Some of my colleagues suggested that I add in the long term, but if I had said in the long term, like nobody would have shown up, right? So I am going to try to make up the case on why we need to do it, even though it seems like it adds a lot of time at the beginning. And I actually have a use case of one of my customers, and that's what we're going to be using as to explaining why it would have been better to have done unit testing. My name is Fabiola de la Cueva, and for those of you who have been here, you already know this joke. You can call me Fab, as in fabulous and modest. Emphasis on the modest part. That way you will always remember my name, so call me Fab. I'm a certified architect, a certified professional instructor, and a LabVIEW champion. And recently I became, my company, Delacor, became an alliance partner. Okay. And we're very excited. We're expanding. Chris Robert, who just presented on the Going Large, and he's back there, just joined Delacor, and we're starting as partners. And he is Delacor Europe, and I'm going to continue to be supporting the US. If you want to learn more, just please visit delacor.com. And like I mentioned, we're also going to be posting some links to this presentation and other presentations that we have done. Is this presentation for you? Does your requirements change in all your projects? Okay. You work on medium to large projects. Yes? Anybody here on the small projects? Okay, I'm still gonna have something for you, or hopefully. Your small, quick, 1 week projects, the typical proof of concept. I'm just doing this really quickly. I will never use it again. They come back for more features. I have one customer that called me like after 2 years, and he said, Fabiola, remember that program you did for us? And I'm like, I don't have source code control for this guy. I don't have a virtual machine. What project did I do for him? Well, I went back and visited, and it turned out that a POC, the name of the VI was POC, proof of concept, was at the center, at the core of this application, and this spaghetti code was irradiating. And I was like, I didn't do that for you. Your team has multiple developers with different levels of proficiency. You believe in unit testing or just testing, but you never really find the justification to do it, or you haven't been able to justify it to your boss. So that's the other one. Also, if you are this guy, you probably don't want to be testing your code on production line. You probably don't want to add a new feature and just have your client or your end customer, your end user be the one that finds that little mistake you make, right? So what is unit testing? Okay, there was already one person over here that said that they didn't know what unit testing is. Is anybody in the room don't know what unit testing is? Okay. 2 people are going to learn something today. The rest came from the entertainment. Okay, the unit is the smallest testable part on an application, and testing is just making sure the unit behaves as expected. In LabVIEW, a unit could be as small as just a VI, but you can also define a unit as a class or even as an action engine. Action engine is another term for functional global variable. We use the term action engine to specify that it's not just set and get, but you have other functions to it. And the testing is going to be that for a given set of values entered for your inputs, the outputs are equal to what you expected them to be. For a given stimulus, you get the expected response. It translates from testing hardware. There are mainly two types of unit testing. There's the black box testing and the white box testing. The black cat over there, he's my cat. He's also my code reviewer. You can go look about Robert Ducking. I don't have a Robert Duck, I have a cat. And the white cat is a friend's cat. And I had a little diagram there that imagine that's a VI, And it has a case structure, right? And that case structure is connected, the selector is connected to an error input. So if I do my magic here and show it, I'm talking about this BI. How many diagrams are in that BI? Okay, how many for 2? How many for 1? 3? Okay, I have several 3. There are 3 diagrams. There's the diagram of the entire BI. There's the error, and there's the no error case. And the reason that's important is going to come up later, but I wanted to show that. So black box testing is when you take the outputs and you make sure that they're equal to the expected outputs. And it's also called acceptance test. I really don't care if you're executing all the typical or possible paths for your code. I just want to know that if this BI was supposed to calculate the maximum value, that it actually gives me the maximum value. I don't care if it creates errors when there's bad input. I just care that it provides the maximum value. The white box testing is the outputs are equal to the expected outputs. And in that case, that's when you need to be aware of which block diagrams, what part of your structure of your code you're exercising. So in this case, you don't only care about making sure that you are fulfilling the function that this BI or this unit needs to do. You're also making sure that you are providing errors when the bad inputs are reported, or that you are covering as many paths your code can take. Does that make sense? Yeah? Okay. Now, this theory is great, but in real life, who has time to do unit testing? By the way, my little guy here, he's more like the CLAD or the CLD or the guy that just started using LabVIEW. The guy with the plus, that's the super CLA. Just reference here. So I'm going to start making my case. So we're going to start with sample case. This was a customer of mine that is making, I'm going to call it medicine. It's radioactive. And the lot number for this medicine is of the form month, day, year. There is a particular function that has to calculate and return the expiration date for this medicine. And it's based on 9 days of decay. I've changed the number of days so you cannot go find out who my customer is. All lot numbers have a Thursday date. That just happened to be, I don't know why. There's probably something with the moon or the calendar or whatever, but all the lot numbers need to be a Thursday. That was part of the requirement. And the reason I was called is because a couple of years ago, a CLAD came up with this solution. Now, I don't want you to spend too much time on understanding the code, but you can see that he went a little overcomplicated here. And there are some nodes that say I changed the less than for or equal because I had a particular problem with a date. There's also problems if the year is the first of the decade. When I saw that, oh, and also if there's an error, if it's not a Thursday, it has a pop-up, a dialog. If you were on my presentation last year, you already know that I hate pop-ups. Pop-up that meant only when it's the end of the world, you're about to format the disk, you really want to make sure. Right? So in those cases, it's okay. But if you are at a really low level on your code, you don't want to have pop-ups at that level. You want to have error reporting. So basically, the super CLA there says, they tried to reinvent the wheel and they ended up with a flat tire. They were not able to cover every single case, right? And it's because they didn't really know what functions were available. But to me, the fact that they were already seeing these comments, they should have had an idea that the code was not working for every date. And they had already tested several dates. But these values were nowhere saved. So we had no way of knowing how they tested the code. So a little bit of background. The code was created around 2008. It took about 2 hours to write. Well, that's what we're assuming because the guy no longer works there, including testing with a couple of known dates. It worked well until January 2013. Now, it worked well until January 2013 means we really didn't realize that there was a problem until January 2013. It might have failed before, but that's when it became evident. By then, the original developer was gone, and even if he was around, I would hope that after 5 years of programming in LabVIEW, he would have been much better and not really understand his own code at that point. It took about 5 hours to find that another problem in another VI on the code was due to this VI. Okay? So they had to call the LabVIEW consultant to troubleshoot and fix the problem. That's me. And we had to stop production for 1 day. The client, not my customer, my customer's client, the one that's purchasing the medicine, was very upset. This is a regulatory environment. We're talking about FDA involvement, and other auditors need to be involved. So what's the cost analysis? Let's say the VI development cost about $200, right? Just a couple of hours. It's a very simple VI. Bug found in 2013. Troubleshooting time, about $500. 1 day production stop, about $10,000. This site has revenues of around $100 million a year. So stopping production for troubleshooting is not really good. For me, it's great because I come like, I saved the day. I came and it was only 1 day that the thing was stopped. It's a huge problem. Incorrect expiration date, the person that actually found the problem was the end user. We found out that the VI that was supposed to do the check before the production went out also had a different bug. This is a regulated industry. If this had caused some problem on a patient, we would have a lot more problems. So we had to, well, not me, my customer had to do a corrective and preventative action incident. We had to do meetings to investigate and plan corrective action. They had to make sure that all the state, federal regulators were informed, You already see that the cost grew, right? Now, compared to if they had just taken 2 more hours when they were developing the VI, and they had also done unit testing, then the cost, yes, it's 2x. But I'm saving in the long run 10x. Now, one thing I want to point out, we should do unit tests not to get a check mark, not to say, oh, I'm great, I work in a regulatory environment, I follow process. We should do it because they save money, they save time, they save my sanity, and because it's the right thing to do. Okay? This is my favorite slide of the entire thing. You know what that window is? It's the VI hierarchy of the project where this little VI that was determining and calculating the lot number was buried in. I don't know how many VIs it is. I just decided I'm just gonna explode this thing and see how far I can go. And I said, okay, feed the entire hierarchy in a window, and there it is. No, we didn't rewrite the whole thing. But the thing that I want to bring to your attention is I get a lot of people that say, especially some architects, especially old-timers, I know my application really well. I know how the whole architecture is done. I know that if I change something there, I'm not going to break something here. And the reality is that when you have a structure of code this big, that has been going on for 5, 10 years, and you have multiple developers with multiple levels of proficiency contributing to it, I don't care how good you are and how great of graphic memory you have. You're not going to be able to tell me with certainty that if you change something here, you're not going to break anything else. Okay? Anybody has a project like this, this size, magnitude? No, you've never actually viewed it like this. When you go back to your desk, you're going to go to your project and you say, okay, VI hierarchy, fit window. So you get an idea of how big your project is. So this is the fixed VI. This is not the code review session, so this is how I decided to solve it. I'm sure there are better ways to do it, but this was the way I chose. Main things to look at is I actually chose a function up here that can do getting the timestamp and converting it into the day of the week, so I don't have to be doing weird calculations like the previous developer was doing. And I also added, instead of having a pop-up for the error, we are actually just checking if it's not a Thursday, I generate an error. And then I let whatever is higher up on the hierarchy to return and inform the user that there was an error. Okay? Okay, so here's where you guys are going like, now you're telling me that I have to test every single VI. This is going to be huge. What am I going to do to manage my code? Right? I'm not here to tell you how to do the unit testing for your code. But I want to tell you some other stories from another customer. If you have to run your entire application in order to test your printer, I wish I could show you that VI, but there's a little VI there in the middle of the spaghetti code that has a little queue, right? Okay. That queue is a cluster of queue references. And it has all the references to all the queues of the application, about 15 of them. And that cluster is sent to every single VI on this given application. So for me to find the VI that actually ends up printing the report takes a while. And I cannot run it by itself because it requires all of those queues to be initialized. So that means that in order to test the printer, we have to initialize the robots, we need to put water in the vials, we need to run the entire thing in order to test the printer. The way we do it, if you're interested, is we do suspend when called on the particular VI that actually does the printing. So when it gets there, we're able to run multiple times the VI by itself. But to do that, I had to run and initialize the entire line. And I still cannot convince my customer to let me just refactor that single VI so I can test the printer. The reason for that is if the code has worked for the last 5 years, and the 3 times that we had spent about 15 hours each time troubleshooting has been when they replaced the computer, when they replaced the printer, and when the printer became obsolete. So by now, he would have already paid a really nice API for his printer. So consider instead creating test code that can be used for testing, shows how the API is used, and documents how the API is to be used. So something like this. I initialize my printer, I add my header, I add my content, I print, I close the printer. You all have your own VIs like this, right? Very simple. So instead, the reason you end up with a situation like this is because you are pressed for time and you start working on the VI instead of working on multiple sub-VIs. And you end up with this huge VI where you added the printing and then you start adding more on it and more on it and then just becomes this huge thing. If instead you go and look at what are the units of your code, you can generate the test for those units. So what do you want to test? Plan ahead, create unit tests for critical code and complex algorithms. Now, does my calculation of the lot number, is that critical code? Actually, no. For that particular application, they did not consider it critical code because it was just generating the lot number. Nobody had thought that it could cause the problems that it ended up causing. And it's not a complex algorithm. So you could at least do this. What I'm suggesting is as your project progresses, add unit tests for bugs that are found that could have been caught via unit tests. If you're doing regression tests, if you are refactoring your code, if you have to modify your code, you have a way to create the unit test first to verify that the new version of the code still produces the same code that the original code did. Even, sometimes you refactor code because the code is difficult to read, you could do this. And create integration tests for every module. One of the advantages of creating integration tests, and an integration test will be like the one for the printer that I showed you that initializes and does the printing. It shows how the API is to be used. Also, a test that runs is documentation that doesn't lie. Does that make sense? You can be typing tons of labels and those labels can go stale and no longer really provide information about the VI that you're working on. But if you have a test that runs and you actually run it and you have a printed piece of paper, you know that the code works. Going to see how the API does the different public calls will give you more information than any documentation in the world. That's not an excuse not to do documentation. I'm just saying It provides a different way of doing documentation. Now, what are the steps? By now, I have you all intrigued. Okay, so how the hell am I going to do this, right? So let me go through the steps that you normally go through when you are developing a simple VI. You set what are your controls and indicators on the front panel are going to be. You write the VI code inside the block diagram. You enter a value on the input, right? Run the VI and visually inspect that the result is what I wanted. Yeah? Everybody does that? Yeah? Okay. And then you move on. Well, what I'm asking you to do is let's find a way to preserve what were those values that you use. And let's find a way to run those tests automatically so you can then later just say, you know, every time I do a new modification, I just run all my tests. And I verify that that hasn't broken any other of my VIs. So what methods could you use to do this? How can you preserve values used for testing? A file? What other options? There's one that is very, very easy in LabVIEW. Because you just set the value in your control, in your input control. Make the values default, right? That's the very least that you can do for preserving. Now, you can only preserve a single value. So if you want to have multiple values, then you have to go to other options. A file that has values or something else. Another thing is that you can have like little step VIs. Oh, I'm going to get to that. If you have a more complex VI, the steps we do is same as before, but then we add a VI that's going to test multiple inputs and compare results. Or you do a little VI like the printer where you have the initialized printing and you can run it multiple times. Now, do you keep these VIs? Do you keep the VIs that you're using right now to test your code? Do you run them ever again? Yes. When do you run them?
Every build.
Every build. And how do you run them?
You set up an automatic run after build time.
So you set up an automatic run. So you already have a test framework. What are you using?
Well, we don't use that. That's how I would do it.
No, that's how you would do it. Okay. Anybody else has? Every time you modify, you manually go and run the VIs? Okay, so for that case, since you already have them probably in a folder, one thing you could do is select all the VIs in the project and then right-click and say Run VI. And it's going to run all of them and pop up all the front panels. And now you can go and visually inspect every VI to see which one passed, right? But in any case, what you want to do is you want to have a way of running all those tests. As your code grows, your test grows. So let's find a way to run these VIs automatically. Test-driven development. So what if I would write a test for the requirement first and then write the code? And then I verified with the test if the VIs meets the requirement. What are the advantages? It leads to cohesive VIs and less coupling. That basically is a fancy way of saying, you know, the VI just does one thing instead of trying to do the spaghetti thing. And I can test it by itself. It doesn't need the entire application, including robots and filling vials with water because I want to test the printer. You can tell that I'm not really happy about that one. Developer can focus on meeting requirements. There's less opportunity to add extra code that is not on the requirements because you're not really focusing at the high level. You are printing a document or you are calculating the lot number, and that's it. I don't care about anything else. I'm just calculating the lot number. The nice thing is that you start having a complete body of tests that is growing along with your code, and it's going to help you with refactoring. This is a book that was recommended at the CLI Summit. I'm still reading it. It's Agile Software Development Principles, Patterns, and Practices. I recommend it. It has a whole chapter on test-driven development. And what Robert C. Martin says is all production code is written in order to make failing unit tests pass. So at the beginning of your project or when you're starting to code the requirements, all your tests fail because the code has not been integrated. I worked with a CLA that would put constants on the VIs, but he would always program the APIs so that all the tests would pass. So the problem with that is that I had the false, when I would go and check his code, I had the false reassurance that we had already implemented all these public methods. So if you're going to do that, the idea is no, you put their values that are going to make the test fail. So you write the unit test, it fails because the functionality for which testing is not there, and then you write the code to make it pass. The nice thing about following these is it changes the paradigm, right? You're not starting from the user interface. You're not starting from the sequence. You're starting from what is it, the requirements that I want to fulfill, and how I want to test for them. And you have a way to have like a checklist. You run all your tests, and you have all the ones that fail because you have not implemented them. And as you start implementing them, you get the check mark. And I don't know about you, but I love to leave a day and have a bunch of check marks on my day.
If you have VR with multiple cases, do you cover all the cases?
That's a very good question. So the question was, if you have a VI with multiple cases, would you cover all the cases? My thing here is that I would suggest that you just do the cases that you're currently doing. So don't do exhaustive testing. Just the way you're testing right now. If you test it by, let's say you're dividing by 0 and you want to make sure that the result is not a number, just preserve that test case. That unit test that you're creating now is a placeholder. If later on you find that there was another bug, if you divided by 1,000, you had something else and it needs attention, you already have a placeholder where you can go back and strengthen that test. If you start over-engineering and trying to make your tests cover every case, then I'm not going to be saving you time and money. You will never get to production, and you're going to be on the front line of some newspaper because your boss shot you. So then don't go to the extreme. I don't want the pendulum to go to the extreme. I'm just saying what you're already doing today, just have a way of document it and make it happen automatically. Make sense? Okay.
How about testing classes?
Testing classes. So I'm going to go to some of the tools. The main thing with the testing classes is now you have to have a creator of the class, initialization of the class, a setup, then the unit under test, and then a teardown. If you are going to be following the printer example, that was a class, right? You would have just a VI that does all the setup. I'll show you how you can do it with unit test framework and VI tester in a minute. There was another question over here?
I'll wait till we cover those, maybe my question.
Okay, if you said here, wait. All right, so more on test-driven development. Tests become an act of design. And the first time I read that, I was like, excuse me? But it's really, like I said, the fact that you start thinking about how the caller is going to be calling your code. Now you have two customers for your code, the test and the actual application. It's a lot easier to figure if your API, everybody understands what API means, the application programming interface, is really conducive for programming when you are focusing in a little test, than going to the major application and realizing, I shouldn't really be passing the cluster of 10 queues to every single VI, should I? Right? And you find that out after you have done 50 VIs that do that. So when you start focusing on the unit, you immediately will say, why do I have 10 queues here if I'm only using one? The API of this section of the code is not good. Does that make sense? So write the VI from the point of view of the caller leads to a stronger, easier to use, and testable API. This also makes your API reusable because it's not depending from other sections of your code. I can take now that VI that prints and use it in another different application as long as it's using the same printer, right? Tests are working documentation for the code. Code that executes doesn't lie. I love that one. If the developer wants to know how to use a function, the test shows you how. Now, this is not an excuse for poor documentation. You still have to do documentation. I'm just saying, Okay, so tools to facilitate unit testing. So before I go on, any questions? No? Is anybody already using unit test framework? Are you using it continuously, or any feedback? What was that? Just tried. Okay. Is anybody using it? All right. Anything you want to say, Chris, at this point?
I'd like to see what else you
Okay. Who has evaluated JKI VI Tester? Okay, who's still using it? Okay, good. All right. Anybody using any other tools for unit testing? What are you using? Okay, but for unit test framework is the 9.1, JKI VI Tester is the one from JKI. Any other tools out there?
Something internally that runs
Something internally that just, and it runs automatically. Okay? Is it written in LabVIEW or in another language? In LabVIEw.
I mean, I use the Google C++ testing framework for C++.
But not for LabVIEw. Yeah.
No.
Yeah, well, that's what I was looking for. Nobody here is using Testen. I've heard using Testen for unit testing. So if you already are using Testen, you could use it because you could program your sequences and call your VIs with given inputs and outputs. This is something that I did not add in the presentation because Testen is not a tool that everyone has, and unit test framework is now included with the developer, the professional suite. And the JKI VI Tester is free. Now it is on the JKI Labs, so it's you know it's not a product that they have on their main page. And but I've been using it for a while now. Okay, so there's the National Instruments Unit Test Framework. The place where I have used the UTF is in regulatory environments, because there you have to report the percentage coverage. This is back to the picture with the two cats and how many diagrams I have. These tells me how many of those cases and my multiple cases I'm actually covering. And because National Instruments is an ISO certified company, that means that in the regulatory environment, I don't need to also certify the tool. I can assume that the unit test framework is certified, and I can trust it, right? So those are the places where I use unit test framework. Here comes the disclaimers. It has improved a lot through the years, but you cannot test VIs that have dynamic dispatch inputs, even if your setup and your teardowns are configured. So that's a drawback, and especially when you have dependency injection when you're testing, you cannot add those.
How about when the VI is re-entering?
What was that?
When the VI is re-entering.
Can you test re-enter VIs in unit test framework? I think you can, right?
What about re-entry C? Do you think it's a challenge to test?
It doesn't report the test coverage. And VI is.
Oh, do you have a sub-VI that's re-entering? I'm not sure.
Yeah, I would have to check that. I don't know. I'll give you my card and you can send me a question about that. So the counterpart would be the JKI VI Tester. Now the VI Tester, you have to develop the test harness. And here you come into a situation where if you have to write code to test your code, who's going to evaluate that the code that you wrote to test the code? Do you see where I'm going with this? Yes, but like I said, you have two users for your code, right? The nice thing about using the VI tester is that I am more comfortable writing code than doing the formatting of the test on the unit test framework. And you could still make mistakes on the unit test framework entering the wrong values. So you're not going to find the silver bullet. There's not going to be there. JKI VI Tester, you can test dynamic dispatch VIs without having wrappers. If you want to use the unit test framework, you need to add wrappers because of what I just described of not being able to test VIs with dynamic terminals. And the other thing that they added recently to the VI Tester is because the JKI VI Tester is based on LabVIEW object-oriented programming, the test cases are objects. You can have your test cases mimic the inheritance of the classes that you are testing. So you can make your test inherit from the other test.
The cases are just your setup and data.
What was that?
Your actual test methods or just your setup and data.
So the question is your actual test methods or your setup and teardown. You could, so the VI tester, because you have used it. The test inherits from the big test, JKI test. You can create your own class now that inherits from the test that you just created to test the lot number, for example. I can show you that offline if you want.
Okay. So trying it like
When did you try it?
like 2 months.
Okay, because Jim did a patch right before CLA Summit, because I brought that up and I thought it was fixed.
Okay.
So, all right, back to this guy. So, the simpler it is to run a suite of tests, the more often those tests will be run. The more the tests are run, the faster any deviation from those tests will be found. And the more testable your code is, the more decoupled it is. So that is, and one of the things that, so this is just a reminder, I have a friend who is bilingual. He's equally fluent in LabVIEW as he is in C. So I hired him because my customer required a DLL, and unfortunately he had a group of C developers, and he asked, if we give you the API, a DLL built in LabVIEW, would you use it? And these guys have never seen LabVIEW in their lives, but they did a Google search and they decided that they would not use it. So we had to write a DLL in C. So what I told my bilingual friend was, I have this set of unit tests for the DLL that is built in LabVIEW, for the source code for that DLL. I want you to do the same functions, right, in C, and then create wrappers for your DLL calls, and they have to pass the unit test that I have already created. So I was able to, directly there test my whole theory here that test-driven development works well. The nice thing is he was done within like 3-4 days. Even my customer was amazed that we were able to return it that fast, because he didn't have to worry about bells and whistles. He already knew, these are my inputs, these are the outputs that I have to provide for each function, and I already know these are the tests that I need to pass. There was a little caveat to that. I was testing some private functions that once he implemented the code in C didn't really make sense to make public, so we didn't create tests for those. Right? Yes?
So I struggle with if I have a particular VI or something, that module that I'm supposed to test, and I have some input data values, and how to save those, and then how to generate them again.
So the struggle is when you want to do a range of values, for example?
No. My struggle is generating those values, those test case values in the first place without running my entire integrated code.
So
I have a valid set of inputs.
So see, that's where I go with it. That's where I show the normal mechanism that when we're writing VIs, we manually set some values, and then the only thing is you would save now those values when you create your test. You won't have a range of values. You will only worry about creating a range of values if you start having bugs that
your input is complex, so that
if your input is complex, you would have to create code to generate that input. Yeah. There's just no way around that one.
There's also the opportunity to look at the modules that are inside that code testing different platforms as well. You can get a higher confidence the further up the chain you go.
Yeah, so Chris is saying that you could, if you have a complex input, there's a likelihood that inside that module there are simpler VIs that you could test, and then that give you a certitude that the calling VI will work, right? Okay, so I like to do videos because you already saw when the presentation began, I get very nervous, so I don't want to be talking and doing this thing. So I'm showing there how to create a VI test. So let me pause the video here and just show you because I know the screen. Basically what we did there, we went to the project, we right click and we said create a test. That creates a new extension. It's called LV test. And this is using the unit test framework. And we are testing the lot calculator. And Chris loves the fact that I call this the wiring by text. Because so you see the image of the VI that you're testing. And it's because I click when I created the test, I told it that was the VI that I want to create a test for. This is, I'm just going to be putting March 6th of 2014. I know that was a Thursday, we say that we needed to do. And it should pass the test. So in this case, I'm just entering the values. And what I'm going to use is up there on the test case, I'm going to tell it to import the values from the, I think it's Control 4. Import values from VI. And what that did is it pulled down the values that I had in my controls and my inputs. So when I said that you could create Ay, ay, ay. Ay, ay, ay. His escape is not working. It's submit. It's submit. Control 4. Yeah, no, it's just I use live Zoom. That's what happened there. So let me forward there. Okay, so it pulled the value. So in the case where I was telling you, you create a test that's going to fail first before you input the code. This is what you would do. You would manually go and enter the inputs and the outputs without running any code, and then import them into the test, so you know what your expected inputs and your outputs are. Does that make sense? And that's without running the code. So you already saw that. It's a repeat. So I'm going to go a little bit farther out. In my case, I know that there's no error, so I'm just going to leave that. And then I just say run. And what that is going to do is run the VI. And I'm going to show you there, I'm going to reinitialize the values to default. So you can see that it actually goes and enters the value. So it's mimicking the thing that we do every time that we create a VI. And what you do is the first test that you create, you put the values that you expect. Does that make sense? All right, so now the next step would be to create the case where I'm going to have an error. Now, one of the things that I found with Unit Test Framework the first time I used it is that down here on the error out, on the comparison, there, it says that it's comparing the entire cluster. The problem with that is that the string, you're not going to be able to match it every time. So what you have to do is where it says on the comparison, instead of selecting equal, you can select by element. And then it will give you a checkbox to just say, I just want to say if the error code generator is 95. Or I want to see if the status is true or false. Okay? It took me hours of going through the documentation, figuring that one out. And the way I found out, and you can look at this video later if you want in your house, LV tests are text files. So I was able to drag this into a text file, and that's how I found out how I can make that show up. So anyway, so of course this one fails. And it fails because the string doesn't match. So what I'm going to do is just show you here pulling the test, the LV test. So I'm going to go explore, drag the LV test file into Notepad. And you're going to see at the bottom of your page here, I'm showing that you have a lot of information. So these files, you can edit them. This means you can have members of your team that you see generate a test for you if you want it, right?
So, since you've shown the text file, I was going to answer your question. You were asking about having multiple test vectors. So what Fab just showed was one test vector. This is the input. This is the output I expect to see. Does it pass or fail? You have a relatively complex input. You can have multiple test vectors. So it's not just one. You have a range of values. Most VIs have more than one input as well. So you want to have a range of values of a range of values, if you like. Editing it here in the test file is a great way to do this because you can actually build this programmatically, if you like. And also the unit test framework has an API in LabVIEW, so you can create API that essentially creates your LabVIEW test.
So what Chris just to summarize that, because you have this right now, I'm just showing a really small test vector. Test vector is all the inputs that I'm providing and the possible outputs. Because it's a text file, you can generate this programmatically. Unit Test Framework has an API, and one of the other videos that I have actually shows doing that also with the generating vectors. So finally, what I found out here was that if I change the word check by the word ignore, that's going to have the same effect as selecting the comparison to be by element. And again, this is probably more detailed than you wanted to see, but I have ulterior motives to show you this. I want more people using Unit Test Framework so I can improve it more.
That's what you discovered it, but now you can edit it
From there.
right?
Yeah, you could go directly to the GUI and edit it there. So I definitely went through the torturous path to discovering that. All right? And that's what I was showing on this video. It was just kind of like the method that I followed. All right, so this is how it happens on JKI VI Tester. You have a menu on your project. You can say new test case. And what that is going to do is going to create a class. How many of you here use object-oriented programming in LabVIEW? All right, so half of the room. So it's going to be a little bit, if you haven't used OOP. But basically what it's doing is creating a library that's going to have my test example. And it has a little template there, and I can create a new test from there and go into LabVIEW. And the JKI VI Tester also has an API, a palette that lets me set passive fail, passive true, passive equal. Yes, the name of your VI, the way it knows which tests need to be run is because they are named tests. So I'm just creating there the icon, and so I'm just replacing the unit under test to be the VI that sets the lot number, and this VI over here, down here, is provided by the JKI VI Tester API, and that's what's letting me, check if it's going to pass if equal. So this is a cooking show, so I'm going to open the oven here and just show you that I have my expected lot, my validate going in, my unit under test, and then I check if both outputs are equal. And now to run it, I go to you can go there. There's also a project palette, but I didn't have the window extended, so I didn't use it. And you'll say test VIs. That opens the JKI VI Tester. Your project has to be saved in order to refresh any new tests that you didn't have there. And then you can run it, and it just gives you the check mark. Okay? Any questions? Yes?
Are any of these available for LabVIEW Linux?
LabVIEW Linux. I don't know. The VI tester, I think it should. Does it have anything that? Yeah, I think you would have to try it out. I don't know if it's. I think they are. I have used them in RT. Both of them, I have used them in real time. I have not used them in Linux or real time for Linux. But if it works in real time, it should work on Linux. But take my business card, send me an email, and I can contact someone at NI, and we can get this answer from both at NI and at JKI. All right, so let's go to the next one. Now, what if the question back there was, what if the lot number is part of a class? Right now, I need to do a setup VI, the VI under test, and a tear down. When you go watch the videos, I keep saying tear down because I don't understand English. There it says tear. Okay. I have not learned how to do this. So if I have a class, you can see that the private data of my class is the lot number and the expiration date. So now I need to have a place to create my object before I send it to the unit under test. There are different ways of doing it. I could be doing it inside the setup VI, or I can do it inside the code. So here I'm just showing you that it's the exact same code that I showed on my previous slide, except now it has an object on the input and an object on the output. So I can no longer do the let's try on the front panel a couple of values and see if I get the right output. Now I need to have code. So the way I would do it, again, let's go to the cooking show mode and open the oven. Of course, I would need like Julia Child always had wine or something. I probably tequila. So this is what you would normally do, right? A little test. Let's go farther. With a little pass fail. Went a little too far. But okay, pause. All right. You guys have done this, right? Yes. So the only thing I'm going to do, and this is where I tell Chris that I'm going to be wiring by text. I'm going to use this as a template that's going to show me which VIs I'm going to be calling as a setup, which VI is going to be the VI under test, and which one is going to be the teardown. So the one that is at the beginning is going to be my setup. The get expiration date will be my my unit under test. So what I'm going to be showing the rest of this little video here is going to the get expiration date, add a new test from the unit test framework that creates my LV test file like it did before, except now we're going to go to the window where I do the setup and the teardown. So I go to the setup BI, and I'm moving this to the left so I can show you. I'm going to look what the name of that BI is, and then use that BI as a setup. And then these two columns tell me what are the inputs of the BI under test and what are the outputs of the setup BI, and I will be wiring by text. Okay. So you say the error in of the unit under test connects to the error out of the setup BI. And again, the visual is the BI that I had just created. Okay.
And this one, you kept your test as a part,
No, the test was it's independent of the that BI actually in this case is not saved because we're assuming we're using the unit test framework. I just use that as a visual, so you would see what is it that we wanted to do, and then the rest is just entering values. Again, like I said, you can go and watch these videos. Put them in slow motion if I'm going too fast, and go at your own pace. All right. Let me just get to, also, I'm checking there, which I did a little bit thing here where I made the expected value be on text instead of timestamp. Another thing that I had to change, and in this case I left the timestamp, but in one of the other videos I had to change it to a string because it was not passing. All right, any questions so far?
On the JKI unit tester that you showed, it seemed to me it was only one case.
No, you can create several. As long as the VI under the test class has the name test, it's going to be discovered by the JKI VI tester.
So you have to create multiple VIs, multiple cases?
It's at this point it's LabVIEW code, so it really is up to you. You can create a spaghetti code to test your spaghetti code if you want. So you can make that VI as expandable as you want, or you can make a smaller VIs and keep it as a separate VIs for each test case.
Yes.
Yeah.
It can be useful if you need to have a test depend on the output of another test. But that the requirement that is extremely rare.
Yeah.
You're not really doing unit testing at that point.
Yeah, it's more integration testing.
Right.
Yeah. So this one I already did. Now here's the case with the test in a class with VI tester. And let me go to open the oven again. We created the class. Okay, so there's the lot test case. And in this case, what I'm going to do is I'm going to put inside the private data of my test case the object that I'm testing, which is the lot number. Okay, so we're back in LabVIEW. We're using JKI VI Tester. The setup BI is the one that is going to be creating the object. So if I have an initialize object or create object, it would be put in here. And because the private data of my test has the lot number, there is where the lot number goes. So in this case, I just used a constant just because there was nothing to do here. But if I was connecting to a database object or creating a printer object, this is where I would initialize and configure my object. And then the teardown is going to call the close VI or whatever is the close connections, for example, if I'm doing a communication test. And if we go back to the test example, it's just going to end up looking very similar to what we already had, except now I'm going to get my lot information from the unbundle by name of the test case. Questions?
What would you do if you have actually have different configuration parameters?
If you want to have different configuration parameters, what you would do is do the configuration on the setup, and you can have, well, depends. You can do the setup for different test cases within the same test class, or have a different test class that has a different configuration. But yeah, I would do it at the setup time. Yeah. All right. Okay, so all right, and now value ranges. This goes into the more complex. If you want to say, for example, I want to test value, the inputs, all the inputs from 0 to 1,000, how would you do that? You can imagine that being on the unit test framework and doing, let me add a new case, 1,000 times might not be so fun. We already said that I could use the API for the unit test framework, or I could programmatically generate it from the text file, or you can manually create a test vector. Now, this is again one of those things that is not very well documented, or as far as I'm concerned, for the creating the test vectors. It turns out that there are two types of test files. There's the LV test, and then there's another one that's called test vector, and they are created from the project. So what I'm doing here is I wanted to test a range of dates, and I'm using LabVIEW code. I'm using LabVIEw code just because I know that all the audience here knows LabVIEW code. But I could have generated that range of dates using Excel or like I said, using another language and programmatically generating them. I just selected to use that because I could drag it into the test vector. So there's the file called LVVect. That's the test vector. This is a different editor than the one that we use for the test. And I'm going to create a new test vector. I'm going to give it a name. I tell it what is the data type. And the reason I use the VI is that in the next window, when I get to assign the values, I can tell it pull all my inputs from the VI that I just created. That it's meant to be the code for the test vector. So I'm saying, okay, I have the expiration date. In the type, you have the option of, like I said here, I'm saying generate list of lot numbers. And I have the names of my inputs and outputs, and that's how I import from the VI that array of values that I had. So that's a lot faster than just, yeah. And that's a sequence. You can also configure, I don't show that on the video, but if you guys send me an email, I can create a video for that. You can also tell it to do it on steps and say, I want you to generate all the possible values from 0 to 1,000, incrementing every 5. Okay? That's another option. So that generates the test vector file. You can give it a name. And now we go back to editing our test, our unit test. And again, this is probably a lot more information that you need at this time. I just wanted to show you when you're ready to try it, you can go check the videos out or send me an email and we can work it out. Yes?
Quick point, the vector file is also human readable text.
Yes. Yeah, and it can be edited with Excel even. The test vector file. So what I'm doing there is I went to the test vector and said, pull the test vector that I just created. You can see that all the numbers that we had created get pulled there. And now I can go to the VI under test and click on the inputs and say, well, there I'm just using the test that we already had, so we just need to create a new one. There we go. So we go there to the lot number, and instead of no vector, I select the range of inputs. And then on the output, I'm going to go to the expected data, to the lot out, and I'm going to say use the vector that I just created. Now, one point that I want to make here, and I don't have a video for that either, but there is a concept of index. Cyclomatic, is that the name? Yeah, there's one feature that your unit test framework has is that you can give it two arrays when you have two inputs. Let's say you are testing an addition. If you are testing an addition, you can give it two arrays and say, unit test framework, test the first input of this array combined with all the inputs of the second array. Test the second input like that. So I didn't create a VI for that, a video for that, but if you're interested in seeing it, just let me know. All right, so that just does that, and you'll see I can add the test vector there and test the range of values. So I don't know, does that help answer the question about more complex?
So when you want to run these test cases, let's say a year from now, someone is going to make a change to the UI and wants to run the same suite of cases.
Mm-hmm.
Can you just pull them out, these test cases, and just run them?
Yes, actually, I hope he was asking if somebody comes a year from now and wants to run these test cases. I hope it's not a year from now. I hope you're every day, right, before you build. Also because you're building often, right? You're not waiting until you're going to be delivering the code. So every time you build run all your tests. All right? So I'm running out of time. You can already imagine that for the JKI VI tester, I also have a video. You just do a VI, and the VI generates the code, and you compare your arrays. So go ahead.
One more quick point. You were talking about running the test cases later. Remember, keep harping on this. There is an API for this. And in your build process, you have the ability to run VIs at certain points during your build process. And I'm going to hand back over to you.
There are API available to run the unit test. For the unit test framework, you can run all the tests available in a project, run all the tests from a file, so you can configure a file. Also, I didn't go through the details, but you can skip tests. It might be that you were running a very exhaustive set of unit tests, and it takes 2 hours to run all the tests, so you want to skip some of them. Unit test framework also lets you put categories of levels for your tests, so you can do that also programmatically. And the VI tester also has an API. So you can, ideal world, you have someone that has already nice framework, you automate all your tests, you run automatically, source code control API, pull all your latest version of your code, then it compiles the code, runs the unit tests, and if something fails, sends an email saying, Chris Ralph broke the code, right?
See, my point is that it's quite easy to write a VI that uses one of these APIs, and then as part of your build process, it's one of the options to run a VI as part of your build process, and it just automatically runs all of your test cases. So
Yeah.
it doesn't matter what you add, doesn't matter what you take away, all of your test cases are run. You get a report from it so that you know if you break something.
So back to my lovely image here. The whole idea is that the last customer I worked with, he was really happy. He said, you guys are so flexible. I had never worked with a group of developers that I could come say, can we change this? And the reason was I would always say, let me try. If it was a small change, I would do the small change, then run my battery of tests and come back and tell him, we have 80% pass. We have 50% pass. And that was a good way of discussing with him how much work was involved on doing these small change, right? So it made it easier. And the other nice thing about having unit tests is that that's my deliverable. Every week, early on, I have something to show my customer. I can run my battery of tests. I can show them the functions that I have already been using. And when you're talking about calculations, algorithms, we are talking now the same language, and they can see what progress I'm making. Okay? So what about connections? If you have databases, that's integration testing. The setup and teardown can help you with that. So choose a unit test tool from the beginning and create tests every time you find yourself testing individual values. So now you said that you were hearing my voice every time about the psychopath. So now every time you're creating a VI and you go into the inputs and you're trying different values and you're visually inspecting, you're going to hear my voice. Have you created a unit test for this? Okay? Sorry. I hope I don't hunt you at night. When a bug is found, if it could have been caught by a unit test, go back and create the unit test. If a bug was found that was not found by your unit test, and this is another important thing. I fell victim of this. Oh, but all the unit tests pass, right? No. Okay, let's go see if it's a false positive or a false negative here. It is better and more efficient to plan and do unit tests from the beginning as opposed to going back and do it at the end. I help companies get through FDA approval, and the last group that I was helping, they didn't want to do unit tests because they were afraid that now they're going to have to prove to the FDA that those unit tests pass every time. So what they decided was we're not going to do any unit tests, and then at the end we're just going to come back and select a handful of them and then create the unit test for them. Now the problem with that is your code might not be testable. You might have a situation where your code is not decoupled. So now you're having to go back and refactor. The reason the FDA is asking you to do this is because they're a pain in the butt. But it's also because they want you to tell them that with this level of certitude, I can tell you that by making a change on my code, I did not break something else. And you can only really, with an honest face, say that if you have a thorough battery of tests. Make unit tests part of your process. Our goal at the end of the day is working software with minimum number of bugs. adapt to changing requirements without breaking existing code. And the unit testing will get us there. So do it because it helps, not just because it is part of the process. I totally agree that neither of the two tools that I show, Unit Test Framework or JKI VI Tester, are perfect. I need more people doing unit testing so we can get better tools. So let's start working toward that. If you have any questions, there's my business card. Like I said, we're running late and we have to go back to a meeting, but I can be here to answer a couple questions. Here's where you can learn more, and thank you.